So we are here with the most likely questions of continuity and differentiability chapter in CBSE 2026 board exam. So the first question I have selected is f of x is equal to k into cos x divided by pi minus 2x if x not equal to pi by 2, 3 if x equal to pi by 2. We are given that f of x is continuous at pi by 2. We are to find the value of k. Okay, k हमें निकालना है. हमें बताया हुआ है कि f of x is continuous at pi by 2. So you know, if f of x is continuous at x equal to pi by 2, the limits x tends to pi by 2, f of x will be equal to f of pi by 2. So this gives me limit x tends to pi by 2. In place of f of x, I'll write what? This k cos x divided by pi minus 2x equal to 3. Now see, if we substitute to evaluate this limit, if you see, if we plug in the value of x as pi by 2 in numerator and denominator, we get 0 upon 0, right? 0 upon 0 is a problem. So what do we do here? Do not use L'Hopital's rule in board examination. So we use pi minus 2x is equal to h. When x tends to pi by 2, h will tend to 0, right? So over here, my limit in the new variable will be limit h tends to 0. Now this is k. In place of x, I'll write what? Pi minus h upon 2. We can clearly see x will be what? Pi minus h upon 2. And over here, this will be h. And f of pi by 2 is 3. So if you solve this further, it is limit h tends to 0. This is k sine h upon 2 divided by h. Pi by cos pi by 2 minus h by 2 gives me sine h by 2. This is equal to 3. Over here, to use the standard limit formula, we multiply and divide by 2. So if I highlight this part over here, this part will become 1. So we'll have our limit as k upon 2 is equal to 3. So this gives me k equal to 6. You can pause and check out this question. I'll move to the next one. So the next one asks, find the value of a if the function f of x equal to 2x minus 1 given that x is less than 2, a given that x is equal to 2, x plus 1 given that x is greater than 2 is continuous at x equal to 2. So see, how do I solve this? Basically what I'm gonna do is, we are given that our function is continuous at x equal to 2. So we know that for a function to be continuous, limit at x equal to 2, limit x tends to 2 minus f of x will be equal to limit x tends to 2 plus f of x. Now this gives me equal to f of 2. Now this gives me limit x tends to 2 minus. When we plug in the value of 2 minus, it means what? 2 minus means it is slightly less than 2. So which function is less than 2? It is 2x minus 1, right? So 2x minus 1. Which function is greater than 2? It will be x plus 1, right? And over here, what is f of 2? f of 2 is simply a. F of 2 is simply what? Simply it is a. So if you see, if we equalize both this with this and this one with that one, you will have limit x tends to 2. You can equalize either one of them actually, but you will get the same answer. Limit x tends to 2, x plus 1 equal to a. So if you put the value of x as 2, a will be 2 times 2 minus 1, which is 3. Likewise, over here, your a value will be 2 plus 1, that is 3. Okay, so my answer is basically what? It is 3. Okay, so moving on to the next question. We have this question over here. Differentiate differentiate um, tan inverse of square root of 1 plus x square minus 1 upon x with respect to sine inverse 2x upon 1 plus x square. So we are to differentiate tan inverse of square root of 1 plus x square minus 1 upon x with respect to sine inverse 2x upon 1 plus x square. So see, if you let u is equal to tan inverse of square root of 1 plus x square minus 1 upon x, and if you let v equal to sine inverse 2x upon 1 plus x square, basically the question asks you to find du by dv. When they ask you differentiate this with respect to that, they are asking you du by dv. So du by dv, can we write that as du by dx upon dv by dx? Of course we can do that. Okay, so basically over here we will have to differentiate u with respect to x first, and then v with respect to x, and then basically divide both of them. Okay, so over here, what is my u? U is tan inverse square root of 1 plus x square minus 1 upon x. V equal to sine inverse. Let us solve the u part first. Okay, so basically what I'm gonna do is, to find the derivative, I'm gonna simplify this. Okay, x equal to tan theta. If you let x equal to tan theta, what do you get? This is tan inverse of square root of 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta is sec square theta, which will give me sec theta minus 1, and this is tan theta. What we can do over here, if you multiply both top and bottom with cos theta, okay, what I'm gonna do is I'm gonna multiply both top and bottom with cos theta. You will have 1 minus cos theta and over here sin theta. Now you should be knowing your trig identity, that 1 minus cos theta is simply 2 sine square theta upon 2, and sin theta is 2 sine theta by 2 cos theta by 2. So if we cancel out the 2's, we will have tan inverse of, this is simply tan theta by 2. So this is theta by 2. So u is theta by 2. That will give me u as half of, if theta was, I think x was tan theta, so theta will be what? Tan inverse x, right? So in place of this theta, I can write u as tan inverse x. Okay, so du by dx is simply gonna be half of tan inverse derivative is 1 by 1 plus x square, so 1 by 1 plus x square. So we'll mark this as equation number 1. Now in the second part of the question, I have v equal to sine inverse 2x upon 1 plus x square. So v is sine inverse 2x upon 1 plus x square. Now again you will know, if you let x is equal to tan theta, over here you will have sine inverse 2 tan theta upon 1 plus tan square theta. Now from your trig identity, this is simply what? Sine 2 theta. Sine inverse of sine 2 theta will give me 2 theta. V is equal to 2 theta. So I can basically write this V as 2 tan inverse x. Okay, so dv by dx is gonna give me 2 upon 1 plus x square. So if you see, if you mark this as equation number 2, I needed du by dv. So if you divide both equation 1 and 2, you are gonna get 1 upon 2, 1 by 1 plus x square, and over here 2 divided by 1 plus x square. So this 1 plus x square, 1 plus x square will cancel out. So du upon dv is simply gonna be 1 upon 4. We'll move on to the next question. So the next question over here is we have to prove that questions are extremely likely in your exam, so it's highly recommended that you should be doing these questions. Okay, so we have, if x to the power y is equal to e to the power x minus y, then show that dy by dx equal to dy by dx will be log x divided by log of xe whole square. Now what I'm gonna do over here is I'm gonna take log of ln on both sides. Basically, you should be knowing that in calculus when we write log, the base is e. So this is log of e to the power x minus y. Now from the properties of logarithm, the y will come forward, and over here again x minus y will come forward. This log of e is simply what? 1. So y log x is equal to x minus y. Okay, so what I can do over here is, if you y log x plus y, this is gonna give me x, now over here if you take the y common, you are gonna have what? Log x plus 1, which is equal to x. So we can basically write this y is equal to x upon log of x plus 1. Okay, now what I'm gonna do is I'm gonna apply your quotient rule. Okay, if you apply the quotient rule over here, you will have 1 plus log x, which is gonna get squared up. Okay, then log x plus 1 will come out, and I'm going to differentiate x. So d by dx of x minus this x will come out, and we are going to differentiate log x plus 1. So this is going to give me log x plus 1, and d by dx of x is 1 minus x into 1 upon x. And over here this will be 1 plus log x whole square. See, so this gives me log x plus 1 minus 1. So this will give me 1 plus log x whole square. So 1 and minus 1 gone. So this basically I have log x divided by 1 plus log x whole square. So this is log x. What is 1? 1 can be written as log of e plus log x whole square. From the properties of logarithm, we can write this as log x upon log of ex whole square. So this is what you needed to prove, right? So this is a very important question, so you please note it down. Next question is a question from logarithmic differentiation. So we have find dy by dx if cos x to the power y is equal to cos y to the power x. So what I'm going to do over here is I'm going to take log on both sides. So if you take log on both sides, you have log of cos x to the power y. This will be log of cos y to the power x. So this y will come forward. This will become y log of cos x, and this is x log of cos y. Now if I differentiate both sides here, so d by dx of y log cos x, this will be equal to d by dx of x log cos y. So if we apply the product rule over here, y will come out and I'll take the derivative of log of cos x. Then log of cos x will come out and I'll take the derivative of y. X will come out and I'll take the derivative of log of cos y. Then log of cos y will come out and I will take the derivative of x. So see, this is y. What is the derivative of log of cos x? It will be 1 upon cos x, but via chain rule I'm going to differentiate cos x, which will give me minus sin x. This gives me log of cos x and dy by dx. Then this is x divided by cos y, and the cos y derivative is again minus sin y, but we will have a dy by dx over here. Then this is simply plus log of cos of y. So this gives me sin by cos is 10, so minus y into tan x plus log of cos x into dy by dx. This is minus x tan y dy by dx plus log of cos of y. So what I'm going to do is I'm going to transfer this to this side. Okay, so log of cos x into dy by dx plus x tan y dy by dx, and this will come over here, so it will become log of cos of y plus y into tan of x. So if we take dy by dx common, we will have log of cos x plus x into tan y. Now this is dy by dx, and over here log of cos y plus y into tan x. So now just divide it. So dy by dx will give me log of cos y plus y tan x upon log of cos x plus x into tan y. So this is my question over here. My question done and dusted over here. So we'll take the next question right away. So the next question I have is, so this question is there in the NCERT textbook as well. Y equal to cot inverse square root of 1 plus sin x plus square root of 1 minus sin x upon square root of 1 plus sin x minus square root of 1 minus sin x. And we are supposed to find the value of dy by dx. Now let us investigate how we can write the square root of 1 plus sin x stuff over here. So 1 can be written as cos square x by 2 plus sin square x by 2. Sin x can be written as 2 sin x by 2 cos x by 2. Then we can write this thing as cos of x by 2 plus sine of x by 2 whole square, a square plus b square plus 2ab. So this becomes cos x by 2 plus sine x by 2. Likewise, square root of 1 minus sine x, this is cos square x by 2 plus sine square x by 2. Then we can write this down as minus 2 sine x by 2 cos x by 2. So this will give me square root of cos of x by 2 minus sine of x by 2 whole square, which is gonna be cos x by 2 minus sine x by 2. Now you see, if we simply plug the values back in, okay, what are we gonna have? We are gonna have, this will be, in place of square root of 1 plus sine x, I have cos x by 2 plus sine x by 2. So this will be cos x by 2 plus sine x by 2. Then this is plus cos x by 2 minus sine x by 2 upon cos x by 2 plus sine x by 2. Then we have a minus sign, minus of cos x by 2 minus sine x by 2. So if you see, also we had a cot inverse on the outside. So if you see, y will be cot inverse. On the top, this will cancel out. We will have 2 times of cos x by 2, and over here this will be 2 times of sine x by 2. So this is gonna give me 2 and 2 will cancel out. So this will be cot inverse of cot x by 2. So which is gonna give me y is equal to x by 2. So now dy by dx is simply gonna be half. Okay, so this is the answer to the question. So the next question goes like, if y equal to e to the power x plus e to the power x plus e to the power x and dot 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 infinity, prove that dy by dx is simply y upon 1 minus y. So now you see, we can simply write this thing as y only, because this forms a chain. If you see, this forms a chain. So we can write this stuff over here as x plus y. Now dy by dx, to solve this thing, what are we gonna do? The derivative of e to the power x plus y, it is simply e to the power x plus y. But then we are to take the derivative of what? We are going to take the derivative of d by dx of x plus y by a chain rule. So this is gonna give me e to the power x plus y can be written as y. This is gonna give me 1 plus dy by dx, and this is simply dy by dx over here. So now this is dy by dx, this is y plus y into dy by dx. So if you take this stuff to the left hand side, you will have dy by dx minus y into dy by dx. This will be y. So dy by dx, this is 1 minus y, this will be equal to y. So this gives me dy by dx is equal to y upon 1 minus y. So this will be the answer to this question. So see, you have to practice all the questions from your NCERT textbook, okay, because all the proofs of the NCERT textbooks are very important. Also the continuity and differentiability questions are important, because CBSE can ask anything. These days CBSE is not sticking to the standard, they are giving setting a very standard paper, कुछ भी क्वेश्चन आ सकता है, ठीक है. टफ questions are expected. You have to be used to it. Okay, so you have to practice NCERT sample papers and all those things, which you think is important looking at the PYQs. Okay, so we are going to do some more questions. Also in the previous question actually we had some condition. uh, Please check your, this is a NCERT question. Okay, over here we had my x was between 0 and pi by 2. Okay, this was the condition given in the question. Alright, so we'll move to the next question now. So another NCERT textbook question. We basically have if cos of y is equal to x into cos of a plus y, okay, then prove that, okay, then we are to prove that dy by dx is equal to cos square a plus y divided by sin a. So what I'm gonna do is, you can see here, if you divide cos a plus y on the bottom, if you take cos a plus y on the bottom and apply quotient rule, you are gonna have x is equal to cos y upon cos of a plus y. Apply quotient rule here, you will have dx upon dy. We are going to differentiate this with respect to y. So just a moment. So we are going to write this as this will be cos square a plus y. Then we are going to differentiate the numerator. The cos a plus y will be outside as it is. The derivative of cos y is minus sin y. Again minus will come out. Take cos y outside and take the derivative of cos of a plus y, which will be minus sin a plus y. So minus minus plus, this is sin of a plus y. Now this will be sin a cos b minus cos a sin b, which can be written as sin of a plus y minus a, minus y, sorry, and over here this is cos square a plus y. I'm applying the formula. Sin a cos b minus cos a sin b is sin a minus b. So this will give me dx by dy. This is sin a divided by cos square a plus y. So if you take the reciprocal over here, dy by dx is cos square a plus y upon sin a. So if you see, this is my answer. So we'll move to the next question. So the next question is from differentiability chapter. So we are to show that mod x is mod of x minus 1 is not differentiable at x equal to 1. Okay, I believe that is the next question we have coming up. So yes. So firstly we need to know a function is said to be differentiable. A function is said to be differentiable at any x equal to c if left hand derivative is equal to right hand derivative. That is, limit h tends to 0. Remember the formula for left hand derivative, it is f of c minus h minus f of c upon minus h, and right hand derivative is limit h tends to 0 f of c plus h minus f of c upon h. So my question is, I have to prove that f of x is equal to mod x minus 1 is not differentiable at x equal to 1. So what I'm gonna do is I'm gonna substitute left hand derivative over here. So this is limit h tends to 0 f of c minus h. What is f of c minus h? So we are having this is basically in place of x I'm gonna write what we have this at x equal to 1, so this is basically 1 minus 1, sorry, basically this is mod of x minus 1. Firstly let me write the definition, f of c minus h minus f of c upon minus h. So my c point here is 1, so limit h tends to 0, this will be f of 1 minus h minus f of 1 upon minus h. So I'm gonna plug in place of x I'm gonna plug in 1 minus h. So 1 minus h minus 1 minus f of 1 is simply 1 minus 1, and on the bottom part we have this minus h over here. 1 and minus 1 is cancelled out. Mod of minus h is gonna be simply what, h, and this is minus what, 0, and over on the bottom we have minus h. So this is gonna give me limit h tends to 0, this gives me minus 1, right? But if you check the right hand derivative, what is the formula for right hand derivative? It is limit h tends to 0 f of 1 plus h minus f of 1 upon h. So what is f of 1 plus h? I'm gonna plug in 1 plus h minus 1 on the top. So this is gonna give me limit h tends to 0 1 plus h minus 1 minus f of 1 is simply what? It is mod of 1 minus 1, and on the bottom we have h. So this is limit h tends to 0, mod of h is simply h minus 0 upon h. So this gives me limit h tends to 0, h upon h is simply 1. So if you see, my left hand derivative is negative 1 and right hand derivative is positive 1. So basically I can say that function is not differentiable at x equal to 1. So we have more questions from NCERT textbook and sample papers. You can practice them. Okay. I'll be coming up with more videos from inverse trigonometry, integral calculus and all. So hope you like the questions. Okay. Once you go through everything, any doubts, please let me know in the comment section. Okay. Best of luck for your final exams. Thank you.